Hello class, just wanted to make another video on the F distribution and the F statistic. Actually it's called the Fisher test, and it's also called a ANOVA. The ANOVA that I'm going to do is called an analysis of variance. I'm just going to do a one-way ANOVA with one independent variable. You can do multiple independent variables, and then you'll get into block design, two-way ANOVAs, MANOVAs, then you're getting into what's called multivariate statistics. Can get very complicated, but for elementary statistics, I'm going to stay with a one-way ANOVA. Now the ANOVA, as before with the distributions we've been looking at so far, we've been looking at pretty much a normal distribution with a mean that cuts the two distribution into two equal halves with the Z distribution and the T distribution. Now with the T distribution, we can use smaller sample sizes, and we have a family of distributions that change with the degrees of freedom. So you can have a flatter distribution if you have a low n, like an n of 5 or something like that. As the n increases to 30, it will take on the characteristics of a normal Z distribution. So it can fluctuate based on the degrees of freedom. Now, when we look at a t-test, we're usually comparing the means of two samples. It could be dependent samples, can be independent samples, or it can be a sample to a known population. So depending on your data, what you're looking for is going to be dependent on what statistic that you use to test your hypothesis. Now I'm going to go over the steps of the F distribution, but I want us to realize the F distribution has a mean of 0, and it is positively skewed, and we've talked about that. So it's going to kind of look like this, with 0 being the mean. So it's going to have positive scores and no negative scores. So when we calculate this F statistic, we won't have any negative scores to deal with. Now when we use an F statistic, we're comparing the means of two or more groups. Usually if you have two groups, you'll use a t-test or a z-test. But if you have 3 or more groups, then you can use an ANOVA or an F-test. So I'm going to put up some real simple data, and the step 1 to this is going to be your hypothesis. The null hypothesis is going to be that mu1, I'm going to use 3 groups for this example, mu1 is equal to mu2 is equal to mu3, and if you have more groups, you could have 6 groups, you would just put some mu1 is equal to mu2 is equal to some mus of k. So mus of k would depend, the k is going to be how many groups you have. So if I have k that's equal to 3, then I'll have 3 groups that I'm working with. So in this particular example, I'm going to be using a k of 3. So case of 3 would be mu1, mu2, and mu3. And my null hypothesis, what I'm saying is all of those are equal, then I don't have any differences between or within those groups. Now my alternative hypothesis is going to state that some mu is not equal to another mu within the groups. So mus of 1 is not equal to some mus of k. So basically, I'm saying that there's going to be some difference in there. I don't know where the difference is going to be at yet. I would have to do an additional analysis, and that would be called a post hoc analysis to find that. But right now, I'm just stating that there's going to be some difference within or between these three means. So step 2, we go to my notes here, is finding our degrees of freedom. So to find the degrees of freedom, I have to have data. So I'm going to have 3 groups, like I say. I'll have, let me move over here, group 1, group 2, and group 3. And let's just say that I've come up with a new pain treatment. So I'm going to pick 3 people who have chronic pain for group 1 at random out of a lot of people who want to reduce their pain, and I'm going to give them a placebo. A placebo is a fake treatment, and I'm just going to give them a sugar pill or something like that. So I've got 3 people, and I'm going to gauge their level of pain on a Likert scale between 1 and 10, with 10 being the most pain, like excruciating pain, and then 0 being no pain at all, and then some level of pain in between there. So after I have concluded my study with these people who have chronic pain, who I have divided up into 3 equal groups, and group number 1 is going to receive a placebo. Group number 2 is going to receive regular pain treatment like a Oxycontin or something like that, some kind of pain pill. And then group 3 is going to receive hypnosis. So after I have collected my data, group 1, I get their pain levels. So 3 people report that I got an 8 pain level, still in a lot of pain. I got a 7 and a 9. So these people, you know, the placebo did not work on them, so they're still, and that's good because it's not good that they're having pain, but it's good that the sugar pill is not reducing their pain, because that would not make sense. So the people who in group 2, they're experiencing levels of pain, and this person reported a level 6, this person reported a level 5, and this person reported a level 6. Now in group 3, I'm going to say, okay, report your pain after hypnosis, and I have a 2, a 1, and a 2. So, good news there. These people are reporting less pain. But is it less pain? Is it significant? Is it significantly less than the normal treatment of medication? And is it significantly different than the placebo? So I don't know. I'd have to actually do a scientific test to figure all this out. So my degrees of freedom for between groups and within groups, I have to figure this out. So between groups, so degrees of freedom between groups. Is going to be K minus 1. So I have 3 groups here. So I just take 3 minus 1 equals 2. So my degrees of freedom for my between groups is K minus 1, 2. So my degrees of freedom within groups is going to be N minus K. So N minus K is equal to, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 data points. So N is equal to 9. And I've got 3. So I just take 3 away from 9. And so I would have a value of 6. So I have total degrees of freedom is going to equal K, or N minus K, N minus 1. So big N minus 1, so 6, 7, 8. So if I take n, I've got 9 minus 1 would be 8. So that's going to be my degrees of freedom. All right, step 3 is going to be the big one. So now what I have to do is I have to start analyzing my data. And how I'm going to analyze my data, I'm going to find out what my sum of squares between groups is going to be first. So in order to do this, I'm just going to go ahead and